Okay, so we've got a car, mass at the center there. I want to find the shortest time to reach 80 kilometers per hour, starting from rest, if drives from the rear wheels, knowing the coefficient of static friction. So maybe the first thing I do is I'm going to want to get everything in meters per second rather than kilometers per hour. So I think I'll start with that. So 80 kilometers per hour. I'm going to take that times 1,000 meters in 1 kilometer and 3,600 seconds in an hour. And that gives me meters per second of 22.2. Okay, so that'll get us going on that. Now the next thing I'm going to do is I'm going to go ahead and draw in my forces on the free body diagram. I'm going to draw them straight on the car here rather than redrawing it. Okay, so the first thing I have is the gravity. That's acting straight down at G there, and that's going to be 1,500 kilograms. Again, 1.5 megagrams is 1,500 kilograms times 9.8 for gravity. Then I'll have two normal forces. I'll have a normal force at A, and I'll have a normal force at B. Okay, and then the only other force that I'll have is the friction force, and that'll only occur at B there. Okay, so I have my friction force at B, and now because I want to find the fastest that I can do, I want this at F max, right? I want to push the limits of that, so that's going to be at 0.2 times NB. Okay, so that's my free body diagram right there. So now that I've got that, I'm going to go ahead and apply my equations of motion, starting with the sum of the forces in the x direction. Okay, so my forces in the x direction, again, I'll assume x and y like so. Okay, so I have that negative friction force, which is 0.2 NB. That's the only force I have in the x direction. And now that's going to equal the mass times the acceleration. Now, this thing is going to accelerate to the left as well, so I'll throw the negative sign in front of it. And I'll say negative 1,500 times the acceleration. And again, what I'm trying to find is this acceleration, so that then, once I know that acceleration, I should be able to compute the time needed to get up to the velocity. Okay, so I'll move on to the sum of the forces in the y direction, where I have NA and NB acting upward. Okay, and then I have the weight acting downward, which is 14,700. Okay, and that has to equal the acceleration in the y direction, which is going to be 0 because there's no motion vertically. So basically, that's just statics moving vertically. So now I know that basically the two normal forces have to sum up to equal the weight, which is not a big surprise. Now I use my moment equation. Now, I have to sum the moments about g. Well, I don't have to, but the way that I'm going to teach this and move through it, it's always best to sum the moments about g. You can also go about a point of pure rotation. However, we don't have that in this situation. I've got translation, so I'm going to sum the moments about g, and I always want to sum the moments about g to make my life a little easier. So I have NA creating a negative moment, so that'll be 1.25 times NA. I've got NB creating a positive moment, so that's going to be 0.75 NB. And then I've got friction force also creating a negative moment. That's going to be 0.35 times 0.2 NB. That's that friction force. Okay. Now this is going to equal I alpha, where I is the moment of inertia, alpha is the angular acceleration. But of course, there is no angular acceleration. This guy is just translating, so this is also going to equal 0. So what I have here is 3 equations and 3 unknowns, those 3 unknowns being NB, NA, and the acceleration. Those are my unknowns. Okay, so through the magic of algebra, we can solve this out. We can find NA and NB. Well, we can find NB, plug that into N to find A. and I find that A then equals 1.27 meters per second squared. Okay. Now, I know that this acceleration is constant because the only force I have is that friction force, which is constant, right? It's 0.2 times NB. NB is constant because the weight is constant. Everything's constant here. So that acceleration is constant. So I can find that my velocity equals that acceleration times time. And again, I know my velocity, I know my acceleration. From this, I can find that the time it takes to get up to that is 17.5 seconds. Okay, so the main thing to remember here is to sum the moments about g. And you can only sum the moments about the center of gravity or a point of pure rotation, which we don't have in this case right here. But once you get those equations of motions, just solve those algebraically and move on.